All right, let's jump right in. We're about to take a little tour of one of the most amazing factories in the entire universe, and it's right inside your head. We're going to follow the incredible assembly line that turns a silent thought into a spoken word. And we're also going to see what happens when a key piece of that machinery breaks down.
I mean, really think about that for a second. You're hearing my voice and understanding me without even trying. And if you wanted to, you could describe what you're seeing on your screen, just like that. It feels so automatic, doesn't it? But behind the scenes, your brain is running this unbelievably complex program. So today, we're going to pull back that curtain and take a look at the neurological magic that makes it all happen.
Okay, first things first, we need to get our terms straight because this is a really important distinction. You've got language and you've got speech. Language is the what. It's the whole system, the words, the grammar, the rules we use to build a message. Speech is the how. It's the physical act of moving your lips and tongue to actually say that message out loud. The conditions we're talking about today, aphasias, they're language disorders. The problem isn't with the microphone, it's with the software that's writing the script.
So, to really get our heads around this, let's imagine the whole process is like a high-tech factory. A thought goes in one end, and out comes a spoken word on the other side. And this right here, this is our factory's blueprint. You can see it's not a straight line, it's a whole network. It all kicks off with some kind of input, maybe an original idea, something you hear, or something you see. All those signals get funneled into one central spot to get processed. And that central hub, that's called Wernicke's area. In our factory analogy, this is the design department. Its job is to understand language and then drop the first blueprint for whatever we want to say. It picks out just the right words and puts them in an order that actually makes sense. So once that blueprint is drafted, it has to get over to the factory floor, right? Well, it travels along something called the arcuate fasciculus. This is just a massive bundle of nerve fibers. Think of it like a high-speed pneumatic tube, our factory's own personal messenger service, zipping the plans from one department to the next. And where does it end up? At Broca's area. This is our production manager. Broca's area takes that abstract language plan from the design department and turns it into a super precise step-by-step motor plan. We're talking an incredibly detailed set of instructions for all the muscles in your mouth and throat, telling them exactly how to move to make the right sounds. So who are these areas named after, anyway? Well, they get their names from a couple of trailblazing 19th century neurologists, Carl Wernicke and Paul Broca. These guys were some of the first to figure out that specific language jobs were handled by specific parts of the brain. And they also mapped out where these spots are. Broca's area, our production manager, is up towards the front of the brain in the frontal lobe, which, makes sense since that area is all about motor planning. Wernicke's area, our design department, is further back in the temporal lobe, which is a key area for processing stuff we hear and understand. Okay, so that's the factory when everything's running like clockwork. But what happens when there's a problem? Let's start with a breakdown right in the design department. This is something called Wernicke's aphasia. Now, when Wernicke's area gets damaged, something really strange happens. The person can still talk completely fluently. The production line is working just fine. But the problem is their ability to understand language is shot. So the words that come out are often just nonsense, and they can't repeat things back to you because they can't understand what you're asking them to say in the first place. Yeah, it's often described as a word salad. The rhythm of speech, the grammar, it might all sound right, but the words are just jumbled together with no meaning. The design department is sending these flawed, garbled blueprints down the line, and the factory, which is just doing its job, produces exactly what it was told to, gibberish. But this brings up a really key question. I mean, if the messenger and the production manager are working fine, why is repetition so hard? Shouldn't they just be able to pass the sound along and spit it back out? So here's why it fails. It's because to repeat something, you first have to understand it. And in Wernicke's aphasia, that very first step, comprehension, is broken. The sound of the word comes in, but the design department just can't make any sense of it. So without a correct blueprint, there's nothing coherent to send to production. The whole process just collapses right at the starting line. Now, let's look at a completely different kind of breakdown. What happens when the design department is working perfectly, but the production manager just shuts down? This is what we call Broca's aphasia. And this is almost the perfect mirror image of what we just saw. In this case, comprehension is totally fine. The person knows exactly what they want to say, but their fluency is gone. Speech becomes slow, halting, just incredibly difficult.
And, just like before, repetition is impaired but for a completely different reason. You can only imagine how incredibly frustrating this must be. You know that feeling when a word is right on the tip of your tongue? Imagine that, but for almost every single word you try to say. The idea is crystal clear in your head, the blueprint is perfect, but the factory floor has just ground to a halt.
So again, we have to ask the critical question. They hear the word, they understand the word. So what's the deal? Why can't they just say it back? So in this scenario, the first couple of steps go off without a hitch. The word is heard, the design department gets it and creates a perfect blueprint. The messenger delivers it. But the breakdown happens right at the end of the line, at our production manager, Braca's area. The damaged system just can't turn that perfect blueprint into the motor commands needed for speech. They know what to say, they just can't make their mouth say.
So we've looked at two very, very different ways our speech factory can break down. Let's put them side by side now and get a really clear final comparison.
And when you look at it like this, the contrast is just stark. With Wernicke's, you have fluent speech, but no comprehension. With Broca's, you have perfect comprehension, but no fluency. And notice that one thing they have in common? They both can't repeat things. But now we know the circuit breaks in completely different places for completely different reasons.
So here it is. If you take away just one thing, let it be this. Wernicke's aphasia is at its heart a problem of understanding language, and Broca's aphasia is a problem of producing language. One is a flawed blueprint, the other is a broken assembly line.
You know, the ability to just talk feels so simple, so basic to who we are, that we almost never stop to appreciate the unbelievable, complex factory that's working away inside our skulls to make it all happen. It really makes you wonder, doesn't it? What other everyday things that we just take for granted are actually their own kind of neurological miracle?